All right, so welcome to SUSACon. Thank you guys for joining us. This presentation is about PPDM, Dell PowerProtect Data Manager, data protection for K3s and RKE2. K3s and RKE2 are SUSE Kubernetes distributions. I'm Gerson Guevara, and the IHV solution architect dedicated for Dell technologies globally. I have been working with PowerProtect team, product management and development team, for the last 2 years and a half. So we built many solutions. Our agenda today will do an introduction of Data Manager as well as the appliance for PPDM. We also talk about SUSE Kubernetes distributions, how to do the backup and restore of applications running on RKE2 and K3s. On the demo, we also talk about validated designs that we have done. We also share some collaterals and a Q&A. So Dell PowerProtect Data Manager. It protects data. It offers data protection from file system, Windows, Linux. It can also do Oracle backups of the database. It uses Arman, SQL database. In a change, it can protect the change at the database level. SAP HANA, another database. On Kubernetes, it uses the CSI driver to do data protection. For VMware and other hypervisors, it uses VMware VADP API as well as vSphere. It also has the ability to do data protection for NAS as well as storage arrays. PowerProtect Data Manager, it has many features and benefits. Starting from a very nice and easy to use interface. It has a dashboard. You have the ability to follow all the backup policies or backup sets. It will allow you to check the event log if the backups were successful, if the restore were successful, if the schedule is working properly, or retentions. It has all different kind of features like multi-cloud, optimize, and software-defined data protection. The backup sets run. Initially, it does a full backup. From there, is doing incremental backups in order to save time. PPDM uses the interface to create the source. I will walk you through the backup set process. It basically reads the data, scan it, read it. Is also doing the duplication, compression, and encryption in flight and at rest. All the data is transferred into the main environment, which is the data protection appliance. From there, you can have the PowerProtect data domain in a separate data center. It uses internet or any TCP/IP in order to replicate the blocks between both of the appliances. It has the ability to do resume and reconnect of the blocks. So if the internet is not working between the main data center and the second data center, it will continue resuming the files that were not sent to the secondary location. You also have the ability to do cyber recovery for cyber recovery data protection. So it has a specific engine that is able to identify if there is any viruses on those blocks. And it supports many production workloads. You can see them on the slide. Now, PPDM also has the ability to do data protection for public cloud environments. So it has the ability to back up from the public cloud and also replicate the main vault into a secondary location. It can work with AWS, Microsoft Azure, Google Cloud. Similar process. You use the backup set or the backup policy to create a set, specify what sources you're going to back up, and then you have the ability to restore when you need it. Once the schedules are set up, it will continue backing up automatically on the schedule time. So PPDM also, we like to highlight that is a market leader product. It's purpose-built, backup software agnostic, and it has lots of patents. The main highlight in this slide is this line right here. So we have the software is very efficient. So it actually has the ability to do 38% faster backups, 44% faster restores in terms of performance. And in terms of efficiency, it uses 11% less power. In the data center level, it requires 50% less floor space than other solutions. And typically, the duplication has the ability to do 65 to 1, especially on the data domain appliance. It also has secure boot for the security and hardware root of trust as well. It is purpose-built. In this specific appliance, go up to 1.5 petabytes. PPDM covers different sizes of market or enterprises. In this case, we are highlighting a mid-size and a large enterprise. For large enterprises, there are two new solutions. One is the DD9410, as well as the DD9910. The specifications are on the slide. It's really fast to backup. The duplication, it is very optimized. It can work on-prem, and it can also do public cloud data protection. And it also have the ability to do in-cloud protection storage with Apex storage as well, up to 256 terabytes. Now, this appliance, for example, it can be deployed really quick. It will only take 15 minutes for deployment. You can store of the duplicated and compressed data up to 256 terabytes. And it can grow in place or scale to the cloud, depending on the design. And as I said, it has the duplication, cyber resiliency, it's cloud enabled, and you can connect via the interface and also offer disaster recovery. We would like to also highlight the benefits. Everything is via an API, so developers can do self-service in case they would like to do any other interface connected to it. I covered that already. A high level of overview for Kubernetes. So basically, PPDM connects to the Kube API server in order to connect to Kubernetes. If you are using a load balancer, it will connect through the load balancer to Kubernetes. The backups are done to the main data center, and then it can be replicated to the data domain appliance. And it also supports cyber recovery. This slide is important. So application consistent backup for databases are very important. MySQL, MongoDB, and PostgreSDB and Cassandra databases are supported as part of the application consistent backup of databases. This means that it will be able to recover up to the point where the backup was done. So this is an important feature. This is a short support matrix of the different type of Kubernetes distributions that are supported by PPDM. With SUSE, I would like to highlight SUSE Rancher Kubernetes, RKE1 and RKE2, as well as K3s on Slim Micro. For public cloud, it supports AKS, EKS, GKS, and this is on other metrics for the supported storage. So if we talk about SUSE Rancher and Kubernetes and SUSE products, we support SUSE Rancher Kubernetes Engine, RKE1 and RKE2, as well as K3s and Slim Micro. So the backup process is divided in 4 sections. So initially, you need to specify where is the data going to be stored, what asset are you going to protect. In this case, we would like to highlight that we can protect RKE2 or K3s, and it is part of the backup policy. We will protect the namespaces and persistent volume claims when we are doing data protection for K3s and RKE2. So this is the interface. You will need to select the source. This is how you create the backup policy. In this case, we are going to protect Kubernetes. From here, you will need to specify the RKE1, RKE2, or K3s cluster API server via IP or via fully qualified domain name. Once you specify all the information on the port and put a name to the backup policy, you can connect, basically will connect. It will also ask you on how often would you like to backup. So you set up that information, the backup policy is created. This is the backup set. So in this case, we are going to be protecting this RKE2 cluster. Now, you can have here, this is an example of all the different backup sets that you can have. This is going to be pointing to the namespace and the persistent volume claim. This is just highlighting the configuration that we are going to be protecting Kubernetes. And in Kubernetes, we are going to be protecting PostgreSQL. This is the protection policy, which is we are also going to talk about in the demo that we will present. Once the backup process is running, the same interface will let us know the percentage if it's completed and the status of the process. So it's very useful. It will also let us know how long it took to backup as well as how much data was transferred to the appliance. So for the restore process, it's very simple. We just need to identify which is the backup policy or backup set that we would like to restore. We click on it, we select it. For restore process, we have 3 different options. So we can restore to original location to the same RKE2 or K3s cluster where that Postgres database was backup. Or we can restore to a separate RKE2 or K3s cluster to a new namespace or to an existing namespace. So we have multiple options when we are going to restore. So these are the steps for restoring the backup set. Number 1, you have the ability to restore to original location. It also gives you the option to restore to an alternate location. What are you going to be restoring? So we are going to be restoring in number 2, the restore namespace and the selected PVC or persistent volume claims. Number 3 is going to ask you if it goes to original location or alternate location. And number 4, it will ask you if you would like to override that content of the existing PVC or if you have a new namespace, you can also specify that. We have validated designs with PPDM because we have been working for the last 2 years. So on PowerFlex, we did a project for RKE2 data protection. On PowerFlex, we did a project for RKE1 and RKE2, and also with Apex Private Cloud. If RKE2 is running on top of Apex Private Cloud services, with PPDM, we validated that as well. The last project we did with PPDM was K3s, because we are also looking into backup those edge type of use cases where K3s is being used. In the diagram, you see that PPDM has the ability to connect directly to the single node cluster, or if you are using a downstream cluster with multiple nodes, we can also use the load balancer to connect to it. In this one, we are highlighting that we can do the PowerFlex data protection. So the PPDM connects via the load balancer to the downstream cluster in order to back up the data. And then the data is sent to the PPDM data domain appliance. So in these slides, we are highlighting that when SUSE Linux Enterprise Server and Kubernetes, in this case RKE2, is running on top of Apex Private Cloud services, in this case is VxRail. So you have VxRail, the VMs are SUSE Linux Enterprise Server. On top of the operating system, you have RKE2 downstream clusters, and the applications are running on top of the RKE2 downstream cluster. So PPDM has the ability to connect to the downstream cluster and backup of those applications in an Apex Private Cloud configuration. PPDM back it up and then send the data to the data domain appliance. So Simon Stevens will be able to will help us to play the demo.
In this demo, we will see how to protect Rancher K3s Kubernetes cluster workloads deployed on SUSE Linux Enterprise Micro-Operating System using PowerProtect Data Manager. Before proceeding with data protection, let's briefly explore the Rancher K3s Kubernetes cluster setup. In the Rancher Management Server UI, we see a custom K3s cluster with the name TME Solutions. The provider is K3s and the Kubernetes version is 1.26. This K3s cluster consists of 3 nodes, where one node has all the roles and the other 2 are worker nodes. In the case of this custom cluster, TME Solutions, PowerProtect Data Manager can be integrated directly with the downstream cluster node L1DPDVC LD085.hop.lab.emc.com, which has all the roles. For the persistent storage for this cluster, we have vSphere Data Store services, which are integrated using the vSphere CSI driver. For this demo, I have deployed a PostgreSQL application on this cluster within the namespace Postgres TME. And this is the respective PVC that is bound to the PostgreSQL application pod. Let's explore the cluster from the command line interface. We can see 3 nodes on this cluster, 1 control plane and 2 worker nodes. The operating system image for these nodes is SUSE Linux Enterprise Micro version 5.5. As mentioned earlier, we see the namespace Postgres TME, in which the PostgreSQL application pod is running. Let's get the namespace details. We see that the PostgreSQL application pod, PostgreSQL-0, is running. In the PVC, we see the VMware storage class vSphere-CSI-SC. Also from the vCenter, in the container volume section, we see a volume created for the PostgreSQL application. Let's connect to the pod to access the application. We are now connected with the PostgreSQL database. For this demo, I have created a sample database called employee_details. This is the sample table, employees, that I have created on this database. Let's now protect the corresponding PostgreSQL database, PVC, and namespace with PowerProtect Data Manager by logging into the PowerProtect Data Manager UI. We have PowerProtect DD Virtual Edition integrated with PowerProtect Data Manager as primary protection storage. From infrastructure, we select Asset Sources. We see the asset source with the name K3s Cluster, which is my K3s custom downstream workload cluster. I have already integrated the downstream K3s workload cluster with PowerProtect Data Manager using the cluster service account token. After the integration and asset discovery of the cluster is successful, the namespaces and PVCs are available as assets for protection. To continue our demo, let's protect the namespace Postgres TME and its respective PVC, which has our PostgreSQL database running. Let's create a protection policy to protect the respective namespace and PVC. We select Protection, then Protection Policies. Click Add, then enter a name for the protection policy. Select the type as Kubernetes. Select the purpose of this policy. Click Add and select the asset. Enter the primary backup details. Review the summary and click Finish. The protection policy configuration is now in progress. Now that the protection policy configuration is successful, let's perform a manual backup. To do that, we select Protection and then Protection Policies. Select the protection policy and click Protect Now. Now we can monitor the backup job from the Protection Jobs page. The manual backup is now in progress, so we will wait for the backup to complete. Now that the backup has been completed successfully, let's verify the protection copy. Select Restore, then click Assets. Select Kubernetes. Select the namespace. Click View Copies, then select the storage target icon. The protection copy is now available and ready to restore. We will now perform a restore for the PostgreSQL PVCs from the backup copy to a new namespace and verify the data. To start, we click Restore, then select Restore to Original Cluster. Next, we select Restore Namespace and select PVCs. Select Restore to a new namespace. Enter a name for the new namespace, then click Next. Select the PVC, review the summary, and click Restore. Now we see that the restore job is in progress. Let's navigate to the cluster CLI and check to see whether the new namespace has been created. We now see that the new namespace Postgres TME Restore has been created successfully. Let's go back to the PowerProtect Data Manager UI and monitor the restore. The restore is now successful. Let's verify the same from the cluster CLI. Let's get the new namespace details. We now see that the PostgreSQL database pod is running and a new PVC has been created for this application. Let's connect to the PostgreSQL pod and check the database and table on this new namespace. Here we can see that the same database, employee_details, and the respective table employees that was created on the original application pod belonging to the old namespace is now available with the restored namespace. This confirms the successful backup and recovery of namespaces and PVCs that are available in the K3s clusters using PowerProtect Data Manager. For more details about this topic, see our PowerProtect Data Manager for Kubernetes technical white paper and refer to the PowerProtect Data Manager Kubernetes user guide. Thanks for watching this demo.
Okay, so this is a list of different white papers and solutions we have built in the last 3 years. So thank you so much, guys. Have a good afternoon.